Hello everyone. Today I'm going to explain question number 11 from GATE 2023 Life Sciences uh, in chemistry section, which is P section. Which one among the following mixtures gives a buffer solution in a water? So what is a buffer solution? It is a solution which is used to resist a pH change. Buffers have a wide application in biology as well as in chemistry. Buffers are of two types: acidic buffer and basic buffer. Acidic buffer is formed by mixture of weak acid and its salt with a strong base. For example, acetic acid. Acetic acid is an example of weak acid because when acetic acid dissociate, it forms CH3COO minus plus H plus. So it is a weak acid because it does not completely dissociate itself. Um, So acidic buffer of acetic acid consists of sodium acetate, which is a salt with a strong base. Here the strong base is NaOH. Similarly, basic buffers are formed by mixture of a weak base and its salt with a strong acid. For example, ammonium hydroxide. Ammonium hydroxide, when dissociated, forms NH4 plus OH minus, and it forms its salt NH4Cl from a strong acid which is HCl. So coming back to the question, which one among the following mixtures gives a buffer solution? So option A is acetic acid and sodium acetate, which is an example of acidic buffer. Option B is acetic acid and NaCl. NaCl is itself a salt and not a conjugated salt of a weak acid. In option C also there is NaCl and NaOH. NaOH is a strong base. To make buffers, we must use weak acid or weak base. Similarly, in option D also we have a strong base. Hence, the correct option is option A. The next question is question number 21 in the same section. A mixture of 4 peptides. These are the 4 different peptides. Of each consists of 5 amino acids. The first one is proline, lysine, lysine, arginine, lysine. Second peptide consists of arginine, glycine, glutamic acid, arginine, valine. Third is arginine, tyrosine, arginine, glycine, and valine. Finally, the fourth peptide consists of leucine, valine, valine, tyrosine, and proline. All these 4 peptides are loaded onto an ion exchange column at pH 7.2. If a carboxymethyl cellulose, this is the structure of carboxymethyl cellulose, is used as a stationary phase of this column, which peptide will elute first? So, as you can see, carboxymethyl cellulose is negatively charged. So, any species which has a higher positive charge will bind to this column and it will elute last. For this, we need to determine the overall charge on all these peptides. So to solve this question, we need to know the structure of all these peptides, overall charge. So to find out overall charge, we need to know the pKa values. pKa values of side chains as well as the pKa values of the alpha amino groups and alpha carboxyl groups which are present on these peptides. So the general amino acid structure is kind of like this. We have NH2. This is the general amino acid structure. This is the alpha carbon as it is attached to the carboxyl group. And to this alpha carbon, we have R. R is this side chain. So different amino acids have different side chains. For example, tyrosine has a phenol side chain. This is the table of the pK values. Alpha carboxyl, we have pK values for alpha carboxyl groups, alpha amino groups, and the side chain. So we need not to remember all this alpha carboxyl group and alpha amino group pK values. We can assume that alpha amino that marked green in the table, we can assume the pK to be 9, approximately 9. Whereas the alpha carboxyl group, we can assume the pK to be approximately 3. Okay. We should know to solve this question that the side pK values of the side chains, which are given in this third column. So for the positively charged, which is the basic amino acids, lysine and arginine have pK closer to 11 to 12, whereas histidine has a pK which is close to 7, which is approximately equal to the biological pH of cell. So you can remember these pK values in such a way that histidine pK side chain will always be closer to 7. Lysine and arginine side chain values will be closer to 11 or 12. And the acetic amino acids, which are aspartic and glutamic acid, the pK will be closer to 4, which is as same as the alpha carboxyl groups of the amino acid. The remaining polar amino acids, which are cysteine and tyrosine. So tyrosine also has a phenol group, which is closer to the basic amino acid pK values. And cysteine has a pK of 8.3. So these are the few tricks for which you can remember the pK values of the side chain. So the first option, so we now have to draw the structures. This is the important part. We need to draw the structures of the peptide. So first is a proline, the cyclic four-membered ring. This is the proline. The next amino acid is lysine. So from here, the next amino acid starts. So this is the peptide bond. This is a proline. This is carboxyl group of proline, which forms a peptide bond of the amino group of the lysine. Since the direction of peptide is not given, we will assume the direction is from N to C. That is NH2 to carboxyl. This are we assuming? So lysine is a basic amino acid. This is the second peptide bond. We have again lysine. This is the third peptide bond. We have arginine here. Arginine, a special structure known as guanidium, is the guanidium structure. C double bond NH2, NH bond, NH2. This is the guanidium structure. The carboxyl group of arginine. And finally, we have lysine again. This is the carboxyl end of the peptide. So this is the structure of the first option: proline, lysine, lysine, arginine, lysine. This will be in the question. We have the pH of the column as 7.2. Okay. So to determine the charge, this this is the thumb rule which we follow, that at pKa on the scale, the values which lie below pKa, the scale of pH, they will be protonated always, and the values of pH which are above pKa will be deprotonated. When the pH is less than pKa, there will be large number of H plus ions, and thus all the species will get protonated. Similarly, when the pH is greater than pKa, the H plus ion will decrease and the species will get deprotonated. So I told you that alpha amino pKa will be approximately around 8. So the proline, so 8 lies. So if we say the 8 pK is 8, so at pH 7.2, it will fall on the protonated region. So the proline will have positive charge. So this NH2 will be protonated. Okay. Similarly, lysine side chain has pK around 10. So at pK 10, so at pH 7, the lysine will also be protonated. So this will have a +1. Similarly, +1 charge. Arginine also has pK value as similar to lysine, around 11 or 12. So this will also be protonated. Finally, the last amino acid is also lysine. So it will also be protonated. And we also need to consider this carboxyl group here. So the carboxyl group has pK. So alpha carboxyl group has pK around 3. So if the pK is 3, so at pH 7.2, it will be, so the 7 will come here in this region. So it will be deprotonated. So this will have a negative charge. Okay, this proton will get abstracted and it will be O minus. So overall charge will be of this peptide will be +4. This +4 is known as maximum positive charge density of this peptide PKK-RK. Similarly, I have already drawn the peptide structures of arginine, glycine, glutamic acid, the carboxyl group here, arginine again with guanidinium group, and valine. So as seen earlier, the alpha amino group will be positively charged. Guanidinium group will also give us positively charged. Glycine doesn't have any side chain, so it will be neutral, 0 charge. We have glutamic acid. So this is the pK Here is deprotonated species, and here is protonated species, and the pH is 7.2. So at 3 pK, 7 will be in the deprotonated area. So the glutamic acid, the proton will be abstracted and it will have a negative charge. So we'll have a negative charge here. Again, arginine positive charge. Finally, the carboxyl group, it also has a pK at 3. So this proton will also get abstracted and will have a minus charge on the oxygen. So the overall charge will be 3 minus 2. So the overall charge is 1. Similarly, arginine will have here one positive charge. Sorry, this is not arginine. This is leucine. Leucine. Leucine doesn't have any charged side chain. So the charge on the side chain is 0. Similarly, valine also doesn't have any charge on the side chain. So 0. Again 0. Tyrosine. Tyrosine has pKa approximately at 10. So on this scale, we have deprotonated and protonated. So at 10, 7 will be here in the protonated region. So this will be protonated and hence there will be a 0 charge. Finally, we have a proline wherein the carboxyl group, the proton will be abstracted because alpha carboxyl has a pKa of 4. It will be negatively charged. So we have one positive charge and one negative charge. The overall charge is 0. Okay. So coming back to our question, we got for option A, we got +4 as the overall charge. For option B, we got +1, the overall charge. For option C, we got +2. And finally, the option D, which we did now, has a 0 charge. Okay. So all these positively charged peptides will get bind to the carboxymethyl cellulose column, to the negatively charged here group. But the last peptide, leucine, valine, tyrosine, and proline, doesn't have any charge, and thus it won't be bound to the column and it will be eluted first. So the option is D. Thank you.